tech topic series on counterfeit components. This is our third session. I hope some, if not all of you, got to come to some of our earlier sessions. We had some great speakers, and that continues today. We're going to be looking at emerging trends in counterfeit detection and mitigation. And we're going to start off with Navid Asadi from the University of Florida. We also will have Frank Mullaney from iNEMI talking about some of the road mapping activities that he's working on. And then Paul and Ben, who are part of the team that's put this together, we're going to be reviewing our survey results. The survey results discussion is intended to be an open discussion, so we're going to show some slides so you can see what happened in the survey, but we want it to be an open discussion with you, so at that point I would ask you to be able to unmute yourselves and participate in that discussion. But let's get into the beginning of our session today. Just to let you know, previous information is available. I will drop into the chat the URLs here. I would ask also if you've got your camera on, so Anne, if you can shut your camera off, I'd appreciate it. I will drop this URL in the chat so that you can easily find these previous sessions. And then let me just sort of set the stage here on how we've been looking at each of these presentations is around how the counterfeit risk runs through the entire supply chain. So we've talked about this particular slide before, just to sort of show where you're going all different places you could have counterfeits in it. I'm not going to spend a lot of time on it. I think we can look at it again during the survey part of the session if we need to. And but I want to get into our talk. So I would ask you, please keep yourself on mute. If you got questions, put them in the chat window and I will get to those. But otherwise, I want to turn it over to Navid Asadi from the University of Florida. Thank you.
Thanks, Mark. I'll share my screen.
So Anne, if you can shut your camera off, I'd appreciate it so that we can focus on Navid.
Making sure you can see my screen.
I see your screen. Thank you very much.
Okay, very good. Thanks, Mark, and the iNEMI team organizing this series. Good morning, everyone. Great to be here and glad to be able to share some of the work that I've been doing the past, I guess, about a decade now on the counterfeits, electronic components. So a little bit about myself. I'm associate professor with the University of Florida. I've been here since 2015, and my research is mainly focused on physical assurance of electronics, from devices all the way up to the components and systems and system of systems. A lot of the physical assurance techniques includes the wide variety of modalities for imaging, characterization, reliability, failure analysis, reverse engineering, and all physical modalities as much as possible to collect to see how they can be used for detecting a counterfeit, gating, and also at some point to come up with some countermeasures. So the talk here today is, I was told it's going to be 20 minutes, 25 minutes. So it's not possible to include everything. Now I see there's a little bit more time, so I'll try to get into deep some of the slides. But what I have put together in these slide series is some examples and those counterfeit cases that has been happened in the past, have been reported, and techniques that we have been developing, as well as in the whole community, has been developed to detect such counterfeit components. Now, I want to also emphasize again that although we are talking about the components here, but the PCB level, board level, and system of systems, IoT systems, they also include counterfeits here and there. Now, the root and the base of these systems are the components, So the supply chain is very complex, and depending on the points of access through each step through the supply chain, the techniques for counterfeit detection can be vary as well. So let's get into it. The global supply chain of electronics is known to almost probably everyone here. We know how the design to the end user chain is working. It's super complex process. The designers and manufacturers, entities who are involved in testing, distribution, and eventually end user are very much spread across the globe right now. Recently, the past few years, packaging is becoming its own big piece. We hear a lot about the advanced packaging, heterogeneous integration, which is a need to take the microelectronics to the next level, follow the Moore's law, and try to reduce the size, reduce the overhead, and improve the efficiency as much as possible. But that's becoming big enough, and different entities are involved in advanced packaging, which will make this supply chain even more complicated. Now, thankfully, with some of the initiatives like CHIPS Act, there are efforts to bring onshore pieces of this supply chain. We do still have a lot of the other pieces that are not onshore and will make this counterfeit problem an ongoing issue. We had a small, a very brief taxonomy of counterfeits, published this probably about 10 years ago, 8, 9 years ago, which we tried to come up with some high-level umbrellas, minimize as much as possible the variations of the counterfeits. So these topics here for these categories are very self-explanatory. About 10 years ago, up to about 10 years ago, we had a lot of recycled chips that were reported. We still have them in the supply chain. However, due to the awareness of the companies and the end users, seems like in some of the recent reports, the recycled reports have been gone down a little bit. But on the other side, we have the clone and tampered chips, which are also much more dangerous to the supply chain, and we see that they are happening. We don't often get to see the reports of these cases. Tampered and Trojan cases are where you really can endanger the existence of a company. We had cases that I'll talk about them briefly. And on the clone cases, we are talking about pirated IPs, reverse engineering, basically companies who do not spend a penny on research and development, take a physically accessible chip from a market, reverse engineer it, produce something similar, and sell it for profit in the market. These examples that we have seen out there in the market have been quite a few, and I'm going to just talk about a couple of them. The most recent one and big one was back in 2018. Big Hack, Bloomberg published a story about the supermicro motherboards. The claim was there were additional components on the PCB that will manipulate and the data traffic and communication between a processor and a memory. So from the physical standpoint, this was basically replacement and modification of an additional passive component on the PCB, which would give the upper hand to a malicious entity. When these boards go into sensitive applications and infrastructure, including databases, which could be in AWS, CIA data centers, and so on and so forth. Now, these PCBs have thousands of components on them. Maybe tens or hundreds of them will be used per data center per week. So it's really difficult to figure out and inspect all of these components on all of the boards. And it takes it requires a lot of manpower or improved automation. So regardless of whether this claim was true or wrong, the whole community agreed that this is a potential vulnerability. A few years before that, 2014, FBI basically banned the company which was selling the Honda PCBs. These PCBs are used in the Honda cars. These will read the sensor information, communicates with the ECU, and controls and change the engine parameters. The counterfeit ones basically often fail when they are installed, and it would also make it possible for a potential adversary to later down the road maybe hijack the steering and the brake. If you look into these two examples here, we have the original and also the counterfeit one, and some of the very subtle changes and modifications that are visual can be detected using physical inspection. There are components that are missing the correct and proper soldering. There are traces that are disconnected or defected. Components used on those can be modified or misused. And if you also look into this top corner here, there's also a missing component. So the original one has a capacitor and this one does not have one. Similar case with the Bloomberg's big hack news and the impact of them in the end user market is very dangerous and risky, can impact lives and so on. So when we look into this whole spectrum to better understand what are the techniques and solutions to mitigate and detect these counterfeits, from the visual perspective, there is a lot of requirement for the automation. We talk about the components, so not only the components themselves, their locations are important, but also the type of component. Like mentioned here, there are components that can be remarked, so the logo and the marking on it can be not accurate as what it represents the real component. So ultimate tools require to understand everything that the subject matter expert can understand from a PCB. I'm going to go over some of these components that are required for inspection. Logo and text, like I said, on the components is some of the most important parameters to create the bill of material. So for a PCB, the first thing to understand is whether the bill of material is what it's supposed to be on your product. So we have seen cases of ICs with missed pins, bent pins, as well as mis-soldered components. The orientation of some of the components sometimes is very visual to be not following an automation process. So to recognize and understand the authenticity of an original component, we have all these different pieces to put together and create the final bill of material. Now, bill of material is just going to give you the base of the design and functionality of your PCB or your component. The same concept and mindset applies to the components as well. So whether it's a component on a PCB or it's a bare component, you still need to look into the logo, you still look into the marking and make sure that this is really what represents that component. Now, when they go on a PCB, it's a next level problem because there are challenges when it comes to the inspection. But because this is more on the component side, let's look into some of those defects that have been seen out there and reported to better understand this concept. So here, there are a few Intel Flash chips. These are all technologies. I think these were 180 nanometer node technologies 7-8 years ago, or maybe more than 10 years ago. And when we look at some of these chips, there are a wide variety of defects. So one example here is the blacktop coating. So what we have seen that is happening is that the counterfeiter takes a chip, polishes the top surface, coats it with a different marking, and you won't be able to identify it from the top view. So looking from the side and looking into these variation of the color or some of the features that will show the counterfeit components features. We also have these ghost markings. If the polishing has not been done well, you will probably be able to see the leftover and the residue of the original marking if the counterfeiting has not been done perfectly. And also, these are some examples of 3D images. When we look into the 3D images, especially the passive components, the difference from an original and a counterfeit component will be very much the size and the material, because we don't have marking on it. So the right type of material that has been used in a capacitor, or whether that capacitor is supposed to be on the right bounding and pad on a PCB. We have had examples where capacitors were replaced by resistors, and there is a lot of work and a lot of scenarios where from visual structure, a capacitor and resistor will look like exactly the same, and we won't be able to identify unless we really look into some characterization of the components, potentially non-destructive 3D methods like X-ray, to be able to look into inside and internal features of those components. There are a number of other defects that we can refer to when it comes to the counterfeits. Visual defects on the surface and also the encapsulant. So if you look into this polymer encapsulant, there are a number of defects that can be found. Not always they mean that they are a counterfeit. Sometimes these defects or anomalies are because of chips being stored in during the distribution. So we do have those standard processes for storing the chips. However, sometimes they go beyond the protocols that it's supposed to be. But here are some examples, like for the sanding, for the corrosion, mostly for older chips. The obsolete chips, which we have in market, a lot of use for DoD applications and military applications, where the chips are designed to be out there for 30, 40 years, will fuel this part of counterfeiting market. So the list goes on and on. In fact, if we look into other modalities like scanning electron microscopy, and you look into even finer details, you will see differences in the texture as well. So the same Intel flash chips, when we looked into actually some more details of the marking on these chips, there seem to be some differences in the uniformity of the marking. So you look into the sample 1 and 2, and compare the print of the first 3 letters. This is F, L, and A down here. It's different in sample 3. Now, it can be a different method used for printing the markings. It can be a different year, but it's a component. It's a defect. It's an anomaly that has to be reported. Now, again, I want to emphasize again, whether or not that's a counterfeit, it's a next level problem. The first step in understanding counterfeit is to extract all these anomalies and variation of the features. We go into the characterization side and the material side of these components. We look into also some contamination. There are contaminations on the chips. These chips, maybe if they are recycled, if they are cloned or tampered, with different material, there could be signs of contamination from extra material. With an optical microscope, it's impossible to identify these, even with the SEM, but techniques like EDS and other characterization techniques are helping us to detect these anomalies. Now, I want to emphasize that a lot of these techniques, if you're familiar with microscopy and characterization, are not automated. In fact, they require really an expert to run the machines and scrutinize the chip, all sides, all angles, and directions to make sure that the whole chip is inspected. So here we put together all these different type of defects, and we try to bring them into a category, different categories, including physical and also electrical defects. Under the physical, we also have 2 main categories, the exterior and interior. We have about 70 some defects right now that are identified from the exterior defects. Internal, we have again about right now 10, 15. As the new type of chips coming in, new structures are coming in, obviously this list can grow. On the electrical side, which is not something we are focusing here, there are also obviously defects that should be and can be categorized. Now, in order to come up with the standards, it's always important to see what's the whole spectrum of the defects that we are looking at. What is the frequency of these defects to be seen on the components that are coming up? We have been trying to actually work with the community to create a database of these defects. Organizations like ERI are also very useful when it comes to their database and repository of these defects that are out there. But it's always difficult to come up with a nationwide effort to collect these defects. It's, I guess that's where hopefully we'll see more of this community to come together to bring together these reports and hopefully from there create the standards. Like I said, our techniques are for counterfeit detections are very physical. A lot of these techniques are right now with a very dire need of a subject matter expert. There are challenges when we are requiring to use subject matter experts. Obviously, there is human error that can be always through this process. If you are sitting behind the machine to inspect components for hours and long hours a day and week, it's going to be difficult to avoid the errors. There are some of these equipments that are coming with automating some of the steps. I think we are still far from having a fully automated process to do all the modalities, but over the past few years, there have been quite a bit of good improvement in terms of the automation. So here I have put in the very brief roadmap of the needs for the automated inspections, and depending on the physical access to each point during the fabrication, distribution, or as a user, we can have different tools developed as well. So a lot of the focus of what we are doing right now is really at the end of the spectrum. We are looking right now as a community, looking into end user scenario. Obviously, when you have received the component, you don't have much leverage on the process and the distribution. So your only tools to basically make a decision whether you receive a counterfeit or an original piece is to look into all the defects. However, if there are potential point access through the distribution, there are other components and other features that can be also extracted, which will help eventually for a track and trace and faster process of inspecting the components. So it goes along the digital twin concept, which is very much known right now in different communities, in semiconductor obviously as well. However, there's also advantages of digital twin that can be used for counterfeits. For so far, if I want to summarize the activities around the component level counterfeit detection, there are a lot of optical and X-ray work out there. There has been a lot of data collected too. I think even just in some of the groups total, we can fairly say that there are hundreds of thousands of images from components, which will help for AI and ML algorithms to bring in the automation. When we go to the internal features, we obviously need those modalities like X-ray, terahertz, acoustic. We are severely lacking in terms of the data when it comes to the X-ray. Obviously, X-ray is more beneficial for PCBs, but also as we go to the advanced packaging, as we go into the multi-chip structures in a component, there will be more of application of the X-ray in these areas. So more data, the more automation eventually, and the more modalities are covered, eventually we'll be able to do a fast decision making for these components. So I want to make sure that we are all aware that there are electronic methods already in place. We have these electronic test inspection methods that are out there, in-circuit test, flying probe, and bed of nails, and so on. These are already out there. As the PCBs especially get more complicated, it's going to be much more difficult, especially for the PCB electrical inspection will be a little bit more difficult because there are literally astronomical number of functionalities that has to be tested on a PCB with more complexity on the components. So the physical inspection will be really the tool to go. But at the end of the day, having these two techniques to work together, physical and electronic, will speed up this whole process. So I wanna make sure that we don't forget about the electronic methods that are out there. Although the physical can help quite a bit, but the blend of these two will give us the best tools. We talked about the components. We talked about the PCBs, but with the new initiatives in the semiconductor industry, like again, I said in the beginning, with the advanced packaging, this counterfeit problem, I think, is going into a new era. Because what we are having, this is a quick chart. We published a paper about a couple of months ago on this, the ecosystem of packaging in US. And when we look into this packaging, there are really a lot of different companies that are player and contribute into building the final product before it goes to the end user. We talk about the counterfeit components when we are really looking into it from an end user perspective. But right now, our players in the supply chain are also looking into making sure that they don't receive the counterfeit parts from their own supply chain. So if we look into this chart really quick, which is for an advanced packaging, we have chiplet designers, we have the foundries. A lot of these designers are onshore, and all these logos which are colored are in US or have a headquartered in US. If they are grayed out, they are not in US. So we have some, maybe when it comes to the foundries, obviously we have Intel Global Foundry, and it's not representative of all the companies, it's just an example here. When it comes to interposers, again, majority of the interposers are actually, we have a Skywater and an Intel who are working in this area, but a lot of interposers are coming offshore. Substrate and PCB suppliers, we barely have any in US. And if you put yourself in the shoe of a chiplet integrator, before they put together this chip, they need to make these components are not counterfeit. Now, on the other side of the scope, we have also the material suppliers, and each of these can be a counterfeit piece. Equipment suppliers, this is a piece that definitely is a double-edged sword, obviously. So if we need those advanced inspection methods and advanced microscopy to be able to look into these parameters, but as they are also improved, then if they are offshore, obviously it is impacting the whole system. Now, looking into the time, I have still a few more slides to go. I want to summarize all of these or physical methods that we are using here. We talked about a little bit X-ray, optical, and SEM. We really mostly look into the reliability in this talk so far. So there are a lot of other techniques that as a community, we haven't really looked into the details. So when it comes to especially these methods are much more helpful for the advanced packaging, but even just the X-ray and optical, we still need hundreds of thousands of data set to be able to automate this inspection process and come up with the standards for these things. Now, as these techniques are improved, as these techniques are automated, and we have also better blend of multiple modality analysis. They will also help with protecting against the reverse engineering, because if we have enough data, if we are able to come up with unique fingerprints as a sequence of these materials, we will be able to use that also as a fingerprint and help with the security of the chip. So we know there are a lot of assets on chips. We have keys, we have a lot of IPs that are stored on a chip. These IPs or assets are vulnerable to some of these techniques, the physical techniques like the optical and photon emission microscopy, laser fault injection. Now we are seeing the E-beam probing that is getting a lot of attention. So the whole ecosystem is going to change as we go into this, bring in the advanced packaging. We look into the advanced packaging in this market. So we have to look into this future roadmap. We have to make sure that for our counterfeit detection, physical inspection, we are not creating tools that are going to be helping the red teams as well in terms of the attack. So there are some work out there how to make sure that fingerprinting and unique track and trace methods can be leveraged from the characterization methods. So I do encourage, if that's an area you are interested, to look into some of the work out there. So I wanna conclude just with 2 slides. So we are probably one of the lucky labs across the US to have a lot of equipment to be able to do these techniques. We are definitely looking into sharing these facilities, potentially enabling remote access to our equipment, do virtual training. But at the end of the day, for the counterfeit detection, we need such facilities to be more spread across the country, different labs, and for the whole community to work together much closer. It's going to have to be a decentralized activity to improve these efforts. Otherwise, with trying to collect a lot of data and automate, it's just very difficult to do in one lab. And these equipments are not cheap, obviously, so it's costly to acquire and maintain such equipment. But we do need them. We have a lot of academics and also industry labs across the country that are more than capable and have the potential to develop teams, work on these methods, and hopefully help with this area. So my last slide, shameless plug, if you are interested to know about more of the technical aspect of these discussions, feel free to join the conference, IEEE International on Pain. So this is a conference mainly focuses on these topics, and we had it just about a month ago in Huntsville. Next year will be in November 12th to the 14th, and would be happy to see you and get into more detailed discussions in that conference. With that, I would like to conclude and would be happy to entertain if there are any questions.
Thanks, Navid. There is one in the chat. They're asking if the lab is ESD controlled.
We have stations which are ESD controlled. Obviously, having scanning electron microscopes and X-rays, most of the time you are basically sacrificing your chip. The chip is gonna methods may be destructive, but we have stations that where we do the electrical tests. They are ESD controlled.
Okay. Let's see. We do have Hal. You have your hand raised. If you've got a question.
Yes. Good morning.
There you go.
Thanks, Navid. That's a good presentation. I like the breakdown that you have for going through the different sources of counterfeit, how you start and how you break it down as to different methodology. The challenge with that is having a good known die, or have a good known device where if you look at the die from the inside, or if you look visually at the device itself to be able to compare it. Another thing which 15 years ago, it used to be a common practice for device ODMs to do demark and mark, sandblast and remark, or blacktop. You don't see as many ODMs doing that. So it's really an ODM device, but it gives you suspicion that that device might be a counterfeit. The question becomes, you go through all of these and you get to a point, if you don't have a good die to compare it to, is really this good or is it bad? Where do you go from here?
Yeah, that's a $1 million question, I guess. Yeah, great question. I think we have to divide it into two pieces. Right? I mean, one is obviously what are those potential anomalies to identify. That would be the first source of information. Your question, which is the second part, which means based on these anomalies to decide whether it's a counterfeit or not, is not easy to answer. I guess there are different ways right now that we are working on it right now. So one best way is to so the short answer to your question is actually I don't know. The long answer is we can try to minimize the problem as much as possible. So a lot of times when you get a new batch from a different vendor or a company, that batch comes in a whole piece, like you have maybe thousands or tens of thousands of components in that batch. If we have enough automation to be able to identify the ones which are different in that batch or are different from vendor 1 to vendor 2, I think that still gives us some good information, because if I'm a counterfeiter, I'm not going to try to counterfeit everything, because that would be very easy for an end user to identify it eventually at some point. So I'll try to maybe do 1% or 2%, maybe even much less than that. So the goal here is that's why I actually mean about this decentralized process. I think the whole system should be connected if we are looking into, and this will help with when you have wide use. If they are special cases, special components, it will be even more difficult. But at the end of the day, one way to make sure that you are 100% using the right component is full reverse engineering. And we don't want to obviously go into the full reverse engineering. There has been some work out there, maybe try to reverse engineer a few chips in a whole batch and make sure that they don't have their own modification or change in it. But from the non-destructive perspective, the best way, in my opinion, would be have a decentralized method to come up with these standards and try to enforce that into the whole community as they are coming from different vendors. Otherwise, the answer is full reverse engineering. And I want to also emphasize that as we go into these more details and we collect also more data, there is hope for new physics. I mean, if we have multiple data which are coming from multiple physical modalities, and if we have a lot of data from reverse engineering as well, there are potential possibilities to find correlation and correlation between those functionality modalities in a chip versus the defects and anomalies that you find out there. I think we don't know the answer until we collect these data. But right now, the solution will be either full reverse engineering or try to collect as much as data so that you can compare it in a larger batch. Does that make sense?
Yes, thank you. Thanks.
Okay. So Navid and the audience, thank you very much. There are a couple of more questions in the chat, but I'm going to move to our next presenter. So Navid, if you get a chance, you can answer through the chat. Also, if we have time at the end, we will have a bigger Q&A. So we may have an opportunity to ask a few more questions live as well. But I want to make sure that everybody gets the speakers in. So thank you very much, and appreciate it.
Thank you. Sure.
Okay. I assume I can take the floor here, Mark, at this point.
Yes, sir. It's your turn.
Thank you.
You got about 20 minutes or so. Thank you.
Yeah. I may even shave a couple of minutes off that. My name is Frank Malani. I'm the Director of Road Mapping for iNEMI. And essentially what I want to address here is, well, you've been attending a few of these sessions on counterfeit components and their detection. The question is, what's the follow-up activity from an iNEMI point of view? And one thing we have come up with is, well, there is a very natural follow through that dovetails nicely into some of the road mapping activity that iNEMI is currently working on. So let me just talk for a second about the iNEMI roadmap. Essentially, we are trying to move away from a document type of approach to road mapping and heading more towards something which is more concise in an online format, sort of a Wikipedia type view. And the idea is that we're trying to influence investment decisions by those folks who control R&D money, whether that be within industry, academia, or inside governments. So it's around those decision makers and the key technologists that advise them that we're aiming this road mapping at. The scope of it from an iNEMI perspective is electronics manufacturing and along the other aspects which intersect with that along the full product life cycle. And being iNEMI, we actually go from materials all the way through to complete systems. So here are the current active teams. We have more areas that we want to spin up next year. But at the moment, we have teams active in areas like board assembly, PCB, packaging, materials, and in cross-cutting topics like sustainability and smart manufacturing. It's on the smart manufacturing one that I want to focus on here today because there's a very natural linkage to some of the topics that have been discussed on this session and on prior sessions. And it's in the area around data and material handling systems that I want to actually get into. But if you start from how we organize things in the roadmap around smart manufacturing, well, we look at it at three levels. We look at what happens on the factory floor, we look at what happens at the enterprise level, and then inside the ecosystem, because certainly smart manufacturing as a concept in terms of the data and what you do with that data operates at those three levels. And we'll be focused right down at the bottom layer here, at least initially, although it has implications all the way up through the system, on the input materials and components. Another way of viewing this is from a functional standpoint. This is the Purdue hierarchy. And again, as you work your way up through the layers, you can see the various control and management systems that exist that smart manufacturing has to interact with. So the way we've organized the topic to date has been around the data flow architecture, so how you manage the data, connect it, and interface it between the various entities. How that data flow architecture then interacts with the equipment, but also importantly with the input materials and the products coming off, the intermediate products and the final products coming off the line. So you have this concept of material flow and conversion where you're dealing with the management of that as it goes through from entity to entity in the supply chain, but also through to the facility itself, through the factory floor. And then, of course, you have the intelligence sitting on top of that in terms of the digital building blocks, whether that be things like digital twins or AI ML decision making, and the various functions that you want on top of that. Behind all of that, we've also looked at the issue around security. And I'll be touching on that, as you can imagine, going forward as well. Key drivers from a smart manufacturing standpoint are A, improve the efficiency of the production line, B, to improve the quality of the output, C, to improve flexibility, so make it easier to handle smaller batches and reconfigure your manufacturing line more quickly. And then finally, to look at issues around where we have shortages in terms of folks to actually run the factory floor. So these are the kind of main drivers that push us towards smart manufacturing capabilities, and they are things that we're going to be touching on as well. Now, from a road mapping perspective, what we've done to date is we have released one batch of data here around data flow architectures and security for smart manufacturing. And if you go to roadmap.inemi.org, you will actually find that content. Oh, my apologies, let's pull it up. Up on the already live on site, so roadmap.inemi.org. Go down to the roadmap topics, pick out smart manufacturing, and there's an overview article there talking through it. And we also data on the data flow architecture, and then security for smart manufacturing, and you can pick up the information that we have included there on that. So that's live today. The next phase then is to look at digital building blocks and materials flow and conversion. And that's what we're going to be working on early in 2024. So this is where it got interesting, because we were having conversations around the data involved in trying to detect counterfeit components. And we realized that it was a fairly broad, it tapped into a broader subject. So if you start from the bottom left, you know, the physical objects that you're dealing with are the input materials, the components, the subassembly, and the final product. Possibly even software. We haven't figured out yet how that may play in here, but certainly those four are part and parcel of what we're having. And what we're really interested in is the mapping of those physical items to the data. And of course, when it comes to things like counterfeit components, you're very interested in the identity, the source, and the certification of those. But you also, as Navid was talking earlier, it starts to intersect with things like reliability and conformance with the actual specifications. So it deals an awful lot with the test data as well. And you also have other issues around the design, around sustainability, that may tie into that data as well. So there are a number of challenges there in terms of how do you manage that data going through the system, across the factory floor, into the enterprise, and across the ecosystem. You have the issues around how that data then gets mapped, and how do you establish the mapping between that data and the individual components as they're flowing through the system. So there's quite a bit here from a technology standpoint that we need to figure out in terms of what's needed, and what are the solutions that are to be dealt with there. We have done a bit of work on this, but we do know that there's a lot more to do. So the technology issues are listed there on the left-hand side. Things like root of trust, the integrity and security of the data, where the data comes from, the quality of that, and whether or not we can exchange it across the various entities, whether it be individual machines, enterprise systems, or between various companies. So that's the scope of what it is we want to do. And of course, what we're really driving at the end of the day is if we can manage that data correctly in the material flows through the system, we can definitely improve the quality, and we can also deal with flexibility, right? If you want to change as component suppliers, if you want to change the design, being able to manage the changes in the associated data with the components coming through has huge advantages, because it means that you can pick up immediately with your existing systems for quality assurance and control. The work that we want to do from a road mapping standpoint does not exist in a vacuum. For starters, we have a team at the moment working on part placement equipment and board assembly, and they have spent a lot of time detailing what they need from automation over the next 10 years. We have a good idea of what kind of data is required from a sustainability standpoint. That has been discussed in the sustainability teams. And of course, we have the security and smart manufacturing team, and they touched on some of the issues here, but most of their focus was on the IT infrastructure. And we have a couple of line items around the material and the data associated with that, but not as much. We knew that this is going to require a deeper view coming into 24 when we got into the material handling systems. So the roadmap process here, what it is going to be a series of 1-hour meetings. It will probably go on for a couple of months. So you're probably looking at a total commitment in the order of a day, day and a half, spread over 2 months. And we'll be working on 2 key tables. These are the 2 core tables that go into the online roadmap that we have today. And we build them up inside in Word, and some additional narrative then to go around that. So it's not a huge amount of content we have to create when we do this. And nearly all of the work typically is done online during these 1-hour meetings, facilitated by either myself or Linda Wilson, the roadmap manager. So it's a lot of the value there is actually in the discussions that happen around the tables as we're filling them in online during the thing. Then there's a review and publication cycle after that, just to make sure we have the quality of the output and the content. So that's what I'm asking for those interested in engaging in this process to sign up to. It is open to any companies from any entities or from anywhere in academia to take part in this. It's not limited to iNEMI members. It's open to all. If you are interested in engaging in this road mapping process next year in this topic, in terms of the material handling and the in particular focusing in on the data side of things, please drop me a line. The email link will be there in the follow-up slides that will be sent on. But I look forward to hopefully engaging with some of you there to create a further segment in the iNEMI online roadmap. Okay, I'll stop there. Mark, okay. I'll hand it back to you.
All right. Frank, thank you very much. Are there questions what Frank has presented here? So he is talking about the large road mapping activity that iNEMI does on a regular cycle, and we talked as a team and felt that certainly the items that are of concern to counterfeit components that we've been discussing here over the past few months dovetail nicely into a couple of the different areas within the roadmap, and this is probably the most germane one, and would certainly appreciate anybody that is interested in this topic to help us here. So please let me or Frank know your interest, and
we'll get you involved.
We'll make sure everybody gets in touch. There are. It looks like there is some affirmative things in here, that there's a lot of gaps and things, so that's good. There was a question about blockchain. I'm not sure that's really directed at you, but I think is when you were talking about some of the tracing in the roadmap, and I was thinking about it, is there a plan, or I guess in this case from a roadmap perspective, has there been discussion about how cloud-based blockchain should be identified as maybe one of those tools that are available?
This would be an appropriate spot for its inclusion in the roadmap. So the answer is not yet. Here's where the conversation needs to happen.
Okay. But it sounds like Gerald's volunteering to be on the roadmap. Thanks, Gerald. No, that was his question. Anyway, I do appreciate it. So if there are further questions, please add them into the chat. We will have probably a little more time for Q&A at the end of the session. But what I'd like to do is to move into the sharing of the results that we had gotten from our survey. So many of you have participated in the survey that we did. And so we do have those available now. Ben and Paul are going to walk us through those. So I will ask Ben and Paul, if you're ready, let me know, and I will be the slide flipper here.
Sounds good, Mark. Can you hear me?
Yes, and even see you. Look at
Yeah,
that.
I was able to get it working. So
God bless. All right.
it's yeah. So as Mark mentioned, we wanted to end the session here with just a quick recap of some of what folks were responding and sharing in the survey that iNEMI had put out on the topic of counterfeit components to the industry here a couple of months ago. Survey is officially closed, I think, as of a couple of weeks ago, but it was out there and open for members to respond and participate in for several weeks. And we did get some good feedback and some interesting insights. So we'll just kind of jump through a few slides here and talk about that. Really, this is meant to be kind of an open dialogue and discussion. So I think as Mark indicated at the top, feel free to come off mute if you have a comment or question or something to share in this space, because this is really, I think, where some of the biggest value can be derived is having a conversation among peers and colleagues about what we are sensing and seeing in this space in the industry. So just a quick summary then of who actually did participate. We had 33 respondents in total. Relatively low, I suppose, considering the survey was open for a few months and broadcast to all the iNEMI members, through various channels. But of those that did respond, we had a pretty diverse set of industries represented, most of them in the OEM or the OCM space, as well as government and academia as being the number 2 category. And lots of folks on the right side, what's your role and function? Research and development, engineering, obviously, big portions of the pool. Marketing was also pretty common, as well as quality roles overall. Next slide, Mark. Question 3 asked about target industries or market applications that most of us are supporting. And I thought this one was relevant when you kind of put it in the context of the next 2 slides, which we'll get to in a moment. But we can see, the top 3 categories here alone, aerospace and defense, telecommunications, and automotive, all highly regulated industries, and all, sectors that are incredibly sensitive to the risk of counterfeit components, because of the downstream and real world impacts that it can have for end users, as Navid had highlighted at the previous session. So we work in a lot of important industries and areas, and counterfeit is relevant to everybody, no matter what industry or vertical you're in. On the next slide, this basically, we can contrast that information with the responses, and asked in question number 4 here is if your company has experienced counterfeit components in the supply chain. Now, a majority, 2/3 of respondents responded in the affirmative, that yes, they have experienced some sort of counterfeit excursion, but we were pretty surprised that this number actually wasn't a bit higher. For the 1/3 of respondents who have not had counterfeit components, just a lot of questions, right? Is this because your company has completely and effectively managed the risk, and you have such robust controls and standards in place that everything is just ironclad in keeping counterfeit components out of your manufacturing process? Or is this possibly because your company simply hasn't been made aware yet of counterfeit excursions, that they simply haven't been detected or spotted or reported by your employees or customers and things like that? Or is this because your business model just simply, you effectively transferred some of that risk of managing counterfeit to your suppliers or partners elsewhere in the supply chain ecosystem? So lots of questions, really curious from the folks that answered no, if anybody would be willing to share here. How is that possible? Just given the threat environment and the risk that we're up against in this space today. It's pretty curious. You can go to the next slide. This one is also interesting in the context of the previous question. The survey asked if your company performs any sort of risk assessments of products to evaluate the impacts of counterfeit components. And here a majority of respondents said no, which personally to me was a little bit of a surprise, just considering, again, how many of us are supporting critical infrastructure and those highly regulated industries such as defense and automotive and ICT and medicine and so on. Why are risk assessments not a bigger part of your manufacturing process with regards to counterfeit? Is it because they're not considered a worthwhile endeavor? Is it because the organization is possibly just naive to some of the risks or the threat vectors that are out there with regard to counterfeit? So pretty interesting perspective on this one. The left half of this slide shows responses to question number 6. This one asked, what are the most common tools or processes that your company uses to prevent counterfeit components in your products? And here, the overwhelming majority of responses sort of fell into 2 big areas. Number 1 being the procurement process and having those requirements and controls in place to ensure that your sourcing is only happening from OCMs or authorized distributors, and 2, that the organization follows one of the many, recognized industry standards for counterfeit prevention and detection. A couple of the other reasons that were indicated, robust testing and validation processes, certainly very effective. Investing in developing long-term and trusted relationships with distributors and component suppliers, certainly a lot of value in that. And then a few folks did actually mention using AI platforms, presumably for the testing and detection, again, along the lines of what Navid was highlighting earlier. So pretty interesting variety of responses there as well. You go to the next one, Mark. Question 7, this one asks what standards your organization uses or references to protect against counterfeit risk. No big surprises here, I would say. You can see on the right side, basically the top 5 responses in this space. Pretty much what I would expect to see. I mean, we have SAE 6171 regarding testing methods as the number 1 most popular response. Followed by AS 5553, the avoidance, detection, mitigation, and disposition. DFARS 252, 246, 7007, and 8. Those kind of mirror very closely what's in AS 5553. So pretty expected that you would see those 2 very closely adhered to. And then number 4 was AS 6081. Which again is the avoidance of detection, mitigation, but targeted at your authorized distributors, basically. So let's go to the next one here, number 8. This one asked if companies have their own internal counterfeit prevention programs and processes that are being used to protect against counterfeit risks. This one was a free-form response in the survey, I believe, so it wasn't a single select binary yes, no. So we got a lot of different answers. From the 18 folks who did respond, we actually had more no's than yeses, which again is kind of intriguing, given that some of what I was pondering on the previous slides about not doing risk assessments and not having any experience with counterfeit excursions. Again, kind of puzzling that more companies, more respondents do not have their own internal programs or processes to mitigate around this risk. We did have one respondent that offered this anecdote saying, we require inspection of most electronic parts. We test and maintain our own equipment so that sometimes we detect counterfeits during testing and repair. So, helpful piece of insight. Next one here, yeah, question 9. Do you have a counterfeit prevention success story that you would like to share? again, a variety of responses. We had about 10 folks that offered a little bit more in this space. We have caught counterfeit parts before they were used. That's great. That's ideally what you want to happen if you have a effective program in place. Another respondent, we received microprocessors, and when we took x-rays of the devices, even though the supplier claimed that they were from the same batch and date code, it was clear that the die was different from device to device. So having a testing and validation process and procedure in place is absolutely critical so that you can trust what your supplier is selling you, but verify that it is what it is, that it is authentic, because maybe the supplier is not even aware that they've been transacting counterfeit parts. And then the last one here, unfortunately not a success story. Our rejected wafers were stolen, packaged, and branded with our logo and part numbers. Customers who purchased these parts suffered from field failures and returned them to us, where we found them to be made of material that we had discarded. This is I feel sorry for this individual and this organization, obviously, but a great example. I'm glad this was brought up. It really, really reinforces the need and the risk that is posed by scrap material and properly handling of rejects and prototypes and engineering samples and that whole sort of category of product that is not part of your high volume manufacturing finished goods that go to market, but that small subset of parts and components and pieces that don't find their way to the market. How are they segregated, quarantined, dispositioned, and ultimately rendered unusable? Because we do see that a lot across the industry, as folks probably are aware, where scrap material somehow finds its way back into the supply chain, having been remarked to appear as an authentic component somewhere downstream. And I think we can go to the last one here, Mark. Question 10 was, would you like to receive further information related to counterfeit components from iNEMI? What comes next in this space, I think, is largely up to all of us as members and folks who are present on the webinar today. A lot of folks saying, yes, they would like to receive more information and future invites to participate in formulating collaborative plans and addressing the industry problem of counterfeit components. So I think this is a worthwhile conversation. I sit in the supply chain security space, so I look at it from a little bit of a different angle. I think we've got a lot of folks here well represented within quality, and that certainly is another perspective on the counterfeit topic. So welcome people's inputs and thoughts here around where we go next. What else would we like to see from iNEMI offered in this space that we could consider for future webinars or other activities? And I think on the last slide here, we had just some general questions that we wanted to pose to the audience to start to get some conversations happening around what we're seeing and how we're managing this risk around counterfeits. So Paul, if you're there as well, I'll let you kind of walk through some of these questions and see if we can get some responses from everybody that's on the line.
Thank you, Ben. So yeah, we just wanted to have a sort of open-ended discussion. So we came up with a short list of open-ended questions to start that discussion here, in addition to what Ben and Frank and Navid talked about today. So the first question here is, inspections and testing are expensive. How can the inspection process be improved?
Yeah, so this is the point where folks, please unmute yourselves and speak up.
And if we have multiple questions that people want to be addressing, please raise your hand in the chat, and we'll take the questions in turn.
So Navid, please chime in. You should be able to unmute yourself.
Yeah, so I guess yeah, the inspection, and at least the inspection side is something we have been doing over past many years. I would say the short answer is automation. Now that's on the operational side of it, but I guess the bigger question is who's gonna pay to support this automation of these tools, right? I mean, the companies, those who are providing these tools, they have a lot of customers in Asia already. They have their own market. Now, who's gonna work with them to automate it to kind of help? And I have been trying. This has been a question. I have been losing sleep on it, but how to motivate or bring this community together to automate this. To me, I guess a little bit of a more synergy to this will be how the front end in semiconductor is operating now. The only reason that it, in my opinion, that it has been very sustainable was that there is tremendous amount of automation in front end. It comes to the back end, you don't have much. It comes to the inspection, it's literally minimal. So yeah, I don't know how the automation should be improved because a lot of the times, unfortunately, those security groups, especially on hardware side, are the last group that are building a company rather than being the first. So their support, they are more looked at as a cost to a company rather than as some entity that's bringing value to this. Now, that is not something I guess that probably the technical side can do. Maybe regulations has to change, and states, I know state of Florida is right now investing in this area, but I think as long as regulations are the way they are, it's going to be eventually profit-based. And if it's profit-based, you're always going to have someone else who is offering the same component for a cheaper price, and customers, if they are not aware of the problems, are going to go and buy, and then when it's a chaotic and catastrophic problem, they're going to come back, and this is going to just be a cycle and keep happening. So yeah, I guess if you want to look into the root of it, will be automation, but the bigger question will be, what is that motive and incentive for these companies and the community to work on the automation?
Certainly. So on Ben's last slide, where he was talking about a company that had their rejects stolen, the company probably lost significant you know, the customer's view of the quality of their product fell somewhat due to that loss of quality. So maybe it's a cost of business. Maybe the businesses have to do this themselves, or maybe there's a general view that it's part of quality assurance.
Yeah,
as well. So
I've heard it. You know, it's a brand damage item that could be avoided potentially.
Yes, and final inspection as a quality assurance or inspection of incoming parts as a quality assurance control could be a motivation.
There are a couple of comments in the chat, maybe not directly related to this question. I guess one that is sort of related from Mary is she's asking, you know, how much can be pushed back on the distributors? I guess, you know, can higher level of inspection and testing be put in back into the distributors. And I'll throw that out to anybody on the call if you've got an opinion or a thought about that, or Mary, if you want to elaborate on that. Please,
yeah.
unmute yourself. Thank you.
Okay, so because of the amount that my company builds at any one time, we rely heavily on distributors. We're very small volume, high diversity in our builds. And distributors, a lot of times they'll buy directly. Most of our distributors buy directly from the manufacturer. They have a relationship with the manufacturers. Where I run into problems and have seen problems are from product that has come back from one of their customers. And this product that has come back from one of their customers, in one particular case, a manufacturer built a product, had a problem with it. We found the problem, went through the manufacturer, they said, okay, ship it back to the distributor who will ship it back to us. We ordered new parts, and lo and behold, we got the parts that we sent back. I could see our writing on it. So the problem I'm seeing with trying to work with distributors is it's not so much the original parts that they get direct from the manufacturing. It's these little side shipments that they get back from their customers for various reasons, not just for rejects, but some distributors have a buyback. They'll do buybacks. And then there's this whole kind of odd area that's starting to develop where it's like a marketplace, but it's going under an overall distributor logo, like an Arrow. Oh, this is part of Arrow, but it's really not Arrow who is working directly with the companies. It's really more of a marketplace. And boy, I'd like to have the distributors take ownership of testing of these parts. Because like you said, they are expensive. It is expensive to do. We have a lab, we have SEMS, we have microscopes, we have x-rays. We do everything we can possibly do. But you know, we're always worried something's going to slip past us.
Oh, thank you for sharing your story. That's caveat emptor, buyer beware.
Is there an appetite potentially for, as a customer, would you be willing to pay, you know, is there value in some sort of service, paying a little bit more when you buy that component from that distributor, if they could provide a value-added service of testing and inspection on their end before they sell it to you?
Well, my company
and a little bit of that assurance.
Corporate Motorola has limit during 2020 when everything was short. They have gone and worked with a bunch of different brokers where they have done exactly that. And we pay more for those brokers, but those brokers send us test reports.
Mm-hmm.
It's that little gray area where we have these trusted distributors who send us parts directly from the manufacturer, but then have this odd little side business or side deals that they do that we need them to be a little bit more aggressive, and trying to get them to tell us information about their counterfeit programs has been really hard. There is a new movement to do the equivalent of a certification for counterfeit programs. I know of three companies that are currently doing it, but the whole of the distributor base is not. And from what I can tell, these programs are more about getting the product right the first time, you know, and making sure when you get product back from your customers, you know, you're getting the right thing, whatever. But Yeah, somebody posted AS6171. I'm not sure about AS6171, but there are companies out there who are saying that they don't have to test, you know, but then they don't comment about this take back stuff. So yeah, that's something that maybe could be looked into.
Okay, thank you. Bill, I see you've got your hand raised. See if I can unmute you or not, Bill. Hang on, Bill. Sorry, got to get into a different view here. Bill, you should have control of your mic. You should be able to unmute yourself. If not. All right. If you're not able to use your mic, you can type it in the chat window, but let's move on. And Bill, if you get in there, just interrupt me and we'll let you talk. Shall we go to the next question, see what other things we get here?
Let's.
Okay.
So the next question is, would data regarding measurements or inspections during either post-production or production enhance your company's quality or security or design processes? From that last discussion, it sounds like some data would be useful.
Yeah, what data exactly are you referring to? Are you talking about inspecting the parts, or I'm not sure exactly what data you're talking about.
Sure. Well, I intended this to be sort of an open question to raise the question of what data would be useful. So perhaps data that shows that the parts had been inspected or sampled in some way might be useful.
Yeah, I would say so. And because as it was pointed out earlier, and I think this was kind of a bit of an eye-opener for me, because I'm always focused on components, we're buying more and more modules, more and more subsystems. And to have data, and of course the people who make the subsystems, they want you to buy the stuff, but they don't want to give you their board layout. I mean, that's, you know, trying to get something from these manufacturers or somewhere that we have a good idea so that we can check that we're getting non-counterfeit when we buy, because the big distributors don't carry as many modules and sub-equipment. You end up going to second and third parties who are sometimes that they're more reliable because they sell to the government, or at least you hope they are, but other times they are, you know, like Adafruit, which is a hobby shop in some ways. So it makes it, you would really like to be able to check these modules you're buying.
Certainly. So SAE has added a slash sheet to the 6171 standards on module inspection. I'm not current on what the contents of that standard are, but that might be a possibility for that. Now, we've had some comments in the chat about GDEP and ERAI having databases that can be referred to for suppliers that have given counterfeit devices.
And Navid, your hand's up. You're welcome to chime in. Bill also got in to the chat and to basically agree with Mary. Go ahead. Go ahead.
Yeah. Just want to add a couple of quick items here. Yeah, great conversation going on here. 2 points. I wanted to first go back to what Mary mentioned. I think that was important to maybe spend a little bit of time on it. Like, who should we push it to, right? Whether it's the distributors. So I look at it in 2 ways. Like, if we want to look into the upstream and downstream, right? I'll say maybe the distributor is the upstream, someone who you are the customer to. So I guess the question would be, all right, let's see what are the profit margins. Obviously, I'm not gonna like argue who's gonna be responsible, because I guess that's a big question to ask. Maybe at the end it's everyone to chip in. But how about the downstream? Are there, that's a question for me as well. Like, can we look into like who are customers to you rather than providers to you? Are they willing to, let's say, chip in to further support the lab that you have or improve the security of the products? That at the end of the day, they are also the users to it. And it goes all the way down. I mean, eventually the end users are probably Google and Amazon and Facebook. Even goes into the software. I mean, hardware is the root really for all of this, the software that is out there right now. And of course, I don't have the data, but when you look into the profit margins, I'm sure that there are huge differences when it's software versus the hardware. But yet they are the beneficiary of the hardware that is produced and is out there right now. So the second one on this question, the measurements, I think that's also an interesting area. We are also working on it, whether I'll argue on the material and characterization side of it, and that's an area that could be an area of research as well. If there is anything, let's say, through the inspection, through the fabrication of my board, right? If we know that there are certain materials used that have a specific response to a specific modality, I'm just going to throw out, let's say, my material in this board is X and Y, and under X-ray, it has to have this level of attenuation. Now, a sequence of those can be a unique fingerprint. So when I get it as an end user, then I would want to only look into that specific fingerprint to make sure that this is not coming from another company. So it's like a fingerprint and a unique ID, but it's not dependent on digital world where or memory or keys that are stored somewhere, which will make it clonable. So yeah, I mean, back to this measurement and inspections, obviously there are a lot of data that would help with assuring that the right type of materials. I had one slide about raw materials, the substrates, especially on the components and advanced packaging. When you have the substrate coming in, your chiplet integrators are putting the chiplets on it, how they are bounded, your C4 bumps, your RDL. There is really a lot of components there. And if there are some information from those steps, then as an end user, I can just go directly look and make sure that, all right, this is the right response I was expecting to get from my RDL. So most probably my chip is assured from the perspective of the integration. So now the same process for raw material and substrates and so on and so forth.
You're on mute, Paul.
Mark, how are we doing on time?
So
Should
we
move
are
to the fourth
actually
question?
we're a little bit past time, but if folks are willing to hang out, and Ben and Paul, if you've got the time, I'm certainly willing to continue with our questions and have this discussion. I think it's valuable, say, for maybe another 10 minutes, so that we respect folks' day. Is that all right?
Maybe we should jump ahead to the fourth question.
Okay, I'll push us over there then. And so these are the last two questions that we had, and the fourth one is
So the third question is any thoughts on how advanced packaging and heterogeneous integration pose new security issues? And then lastly, what can iNEMI do to make your life better in the space of counterfeits and general hardware security? So as we've been talking about, what are the next steps that iNEMI can do to help out? And how is that different from some of the other standards organizations out there?
one of the things that I will say right now, just the nuances is iNEMI cannot develop standards. We're not a standards organization. We can do specs and research and lots of things that look like standards information, and then our members in the past have taken that and brought it to the IEEEs, the SAEs, and other organizations, and have it turned into a standard. But we're not, just to say, we're not accredited to be a standard development organization.
Yes,
just
thank
to
you.
make that
Thank you
clear.
for that
Just to make that
clarification.
clear, that's all.
Yeah.
But yeah, yes,
Thank
I
you.
think we can make stuff that looks, sounds, and quacks like a standard. It's just not considered to be a standard. It's not a standard, but it can be
Yeah.
carried over there. Yeah, so we heard a little bit about the road mapping activity and from Frank, and trying to identify what are some of the issues. So I think that is certainly one of the things that we can do now. We need folks like we're having in the chat and in these conversations of what is lacking. So we've heard some of the standards, how often are they updated, what kind of certifications should we get and see. There's a whole, I guess I won't even say a side conversation, but a bunch of conversation going on in the chat window if you're not looking at it, about GuideUp and qualifications and certifications and labs, that I think is an interesting point. So I know that's there are areas of investigation in there. We need you guys to tell us. So this is a question of, tell us what you need iNEMI to work on for you, and we will try to work on it. That's our goal, is collaboration.
So there's a good comment in the chat about the need for detecting counterfeit electro-optic devices.
Ben, you were going to say something as well.
I'm wondering if there's maybe a little bit more that could be done with regards to, I think, general training and awareness of this issue, right? This is kind of a niche topic that, as I said before, folks in quality or folks in supply chain security are focused on. But if you work in another area of the business, you probably don't know how prevalent this is, how counterfeit risk can manifest, what to look for, right? Even if you're not formally trained, with technical knowledge and inspection and testing, you can still educate folks, especially those frontline, folks on warehousing, who are doing the shipping and the receiving of goods as they come into the facility before it gets released into shop floor or put away in inventory, or the frontline folks who are doing the work inside the fab or the factory, the assembly and that sort of a thing, educating them on, this is a threat, this is a risk, and here are some basic things that you can look for and things that you can do to help. And the age of, if you see something, say something, right? If there was a way to develop maybe some general training content and assets or collateral that members could possibly use to, share within their organizations to drive awareness, that might be something helpful.
Okay. Any other comments from folks in the chat? Navid's asking, how do we work with I don't even know how to say that, NAPMP. I honestly, I guess that's above my pay grade. I don't even know what NAPMP stands for. So it's possible that iNEMI has a relationship with them. I don't have that relationship myself. So I can follow up with you.
To the best of my knowledge, Mark, that's currently being worked by the CEO, Shekhar.
He is. Okay, great. Wonderful.
Yeah.
Wonderful. Okay.
I can't comment on Chip's things today.
There you go. No comment. So Pringles or Ruffles? Come on, Paul.
Salsa, please.
Yeah, salsa. Salsa's that's definitely the way to go. All right. I will try to take the various things I saw in the chat, make sure that we've addressed those. I will get with the counterfeit team here. We have Ben and Paul here today. Jen is not here with us, but we'll try to maybe make a little Q&A based on some of the things we heard here today, and also have that available for distribution along with the presentation. So we got last chance for comments or questions at this point. All right, so I think the last thing that I have here is just, again, we do have all of the previous meetings online. So if you'd like to see the recordings or the presentations from sessions 1 and 2, and then this session as well, it will be available within the next week or so. I'd say the third session will be posted, and we'll send out a note to all of you to alert you that it's available. We also are having some discussions internally about adding a 4th session in the future, early next year. So we'll see if there could be a 4th session where we can get Terry Munson, who is going to speak today from Foresight about some LIBS technology, but he was unable to clear his schedule. And we do have others that have expressed some interest in this, and I'm seeing a lot of questions about some of the standards. So maybe we need to, even though we had some presentations on the standards, maybe we need to see if we can get someone from SAE to come and talk to us potentially. I'm not sure. I will talk amongst the team. If you're interested in being part of that team, please holler at us. We are looking certainly for contributors to help us decide the direction of what we're going to do here for counterfeit components going forward, other than mitigate them. So everybody, thank you very much for your time. And sorry we ran over, but I think we had some good conversation. And we'll talk to you all soon. Hope you all have safe and happy holidays.